Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem. 190 reverse bits. It's easy marked. We need to reverse bits of a given 32-bit signed integer. Okay, so this is a simple problem, but let's see before starting with this problem, we'll brush up our bitwise operators. Okay, so for now I will only check left shift, right shift and or. Okay, so what is left shift operator? So left shift operator is used to shift bits left side, and right shift is used to shift bits right side, and operator is used to perform with the given bits. Let's take one example. So we have 1010. If we'll do the left shift of 1, what will return? It will return 1011. It will add 1 bit to its leftmost side. Okay, and sorry, it's rightmost side, right? This is rightmost side. It will add at rightmost side. And for the same thing, if we perform the right shift operator, it will remove the rightmost bit and it will give 101. Okay, and the same thing, what is and? So if you perform 1011 and if you perform it on 0001, which is 1, this is 11 and this is 1. 11 and 1 will become 1 and 1 is 0 and remaining things are 0, so it will give 1. So 11 and 1 is 1 only. And let's see or. So or is nothing but it is 11 and 0001, so which is 1. 11 or 1, it will return 1101. It is 11 only. So 11 and 1 will given 1 and 11 or 1 gives us 11. Got it? So these are the 4 simple operations we are going to use in the reverse bit program. Now let's take the same example and let's perform these operations. So let's say we have n is equals to 1011. So we need to reverse these bits. Okay, we should get 1101 as answer. So first initialize our answer with 0. Okay, so now what we'll do is we'll first make a space for the first bit we are going to extract in n. Okay, so what we'll do how to add one bit to the current integer. We'll do the left shift. It will add the bit in the rightmost side. So if we'll do answer left shift 1, what it will return? It will return 0 0. So now our current answer is 0 0. Okay, now what we'll do is we will extract the rightmost bit from this n. How will return rightmost bit? So if you perform AND operator, it will give you the rightmost bit. How? If you do 1011 and 0001. So if you perform AND operator on this, 1 and 1 is 1 and remaining things are 0. So it will give you the 1, right? Which is the rightmost bit. So for example, if you have 1010 and you perform one operator and operator, so with 1, so it will return 0 and 1 is 0 and remaining things are 0. So you will get 0, which is the rightmost bit of this number. Got it? So we need to perform, so for given any number n, so if you perform AND with 1, it will give us the rightmost bit of that number. So what we'll do, we'll just do n and of 1. So we'll get 1 bit, which is the rightmost bit. Okay, now what we'll do is how we can get that, add that number into our answer bit. So what we'll do, we will do OR with the last bit, right? We'll do OR with the last bit. So currently what we have answer, we have 0 and what we have 1. So we'll do the OR. It will give 0 1, which will be 0 or 1 is 1 0 or 0 is 0, so which is 0 1. So now answer will become 0 1. Now we have extracted this bit, right, our last bit, and we added that into the answer. Now we need to perform for the remaining bits. So now what we'll do is we will remove the rightmost bit. What is the bitwise operator used to remove the rightmost bit? Which is right shift. So what we'll do the right shift on the n, so which will give us 1 0 1. Now let's proceed further. We will repeat the same 4-step process until we will get the answer. Okay, now let's see. Now we have 1 0 1 and answer is 0 1. Now let's make one place in the answer. Answer left shift of 1 will give us 0 1 0, and n and 1 will give us the rightmost bit currently is 1. So n and 1 will give us 1 again. So now we'll add that to the answer, last bit. So this is the last bit, right? This is the last bit. So we'll add that into the answer. 0 1 0 and the last bit is 1. So 0 0 1, which will be 1 1 0. Now the answer is, now answer will become 0 1 1. So 0 1 1. And now let's remove this is the n, where is n, this is our n. So let's remove the last bit. Now n will become 1 0 and our answer is 0 1 1. Now let's perform these steps again. We'll make one place in the answer. Answer is 0 0. Now answer will become 0 1 1 0. Now we'll extract one bit from the n, which is 0. So n and 1 will give us the 0. Now add this bit to the our answer. So answer our last bit, so it will return as the 0 1 1 0, again 0, because 0 1 1 0 and last bit is 0. If we do or on, if we perform or operator on this thing, it will return us 0 1 1 0 only. So answer will remain same. Now let's remove the rightmost bit from the n. So now if we'll remove, it will give us 1. So it will remove, it will contain only 1. Now answer is 0 1 1 0 and n is 1. So what we'll do, now we will do the same thing. We'll repeat the same process. We'll make a space for 1. So now answer will become 0 1 1 0, and let's extract the bit, n and 1 will give us 1. Let's add this bit. If we add this bit, answer will become, answer or last bit, it will become 0 1 1 0 1, right? And now we will got the answer. Let's remove the rightmost bit from n. So n right shift 1 will give us 0, right? So now we have we don't have anything, right? It will give us the 0. Now what we'll do is, now we got the answer already, right? 0 1 1 0 1. So but we need to return it as a 32-bit integer. So what we'll do is, we will iterate the for loop from I is equals to 0 to I should be less than 32 times, right? So it will add the remaining zeros, right? It will add the remaining zeros here, right, until we got 32 bits. And if you observe here, our initial integer is 1011, and here we got one extra bit 0, which will doesn't matter us, because we before the zeros are will don't matter. So it is 1101, and we have 32 bits zeros here. Okay, now we'll return the same answer. Got it? Now its time complexity is, out of one time we are only iterating for 32 times. Okay, and we are not using any extra space also, so it will be or of big of n. Now let's write code. We will take a answer variable and let's iterate the loop. I is equals to 0, I should be less than 32, since we need 32-bit integer, then I plus plus. So as I said, let's make a position for the last bit, we'll do left shift for adding one bit, and then we need to extract the last bit from the end. So we'll take int last bit is equals to n and 1. So if you do and with any integer, it will give us the last bit, and then what we'll do, we'll add this into the answer, this last bit. So if you do or, it will add this last bit into our answer. So once we have the answer, we need to remove the last bit from the end. So we'll use the right shift operator, right shift with 1, it removes one rightmost bit. So now it's done. We'll just return the answer. Let's run this. It is accepted. Let's submit this code. Yeah, it is accepted with 0 milliseconds runtime. Yeah, if you like my content, please do like, share and subscribe. Thank you.